Have you at any point investigated whether we're really alone in the universe? Of course, have you expected that there's something more to our reality other than what we see? Imagine what is happening. Think about how possible it is that the James Webb Space Telescope will at last show that we live inside a black hole. Join us as we figure out more about this world, uncovering news that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a spine chiller. Sure, you might have seen them in science fiction movies, but what's significantly more unsettling is that they're not just a made-up idea. According to well-informed experts, black holes in space are enormous amounts of matter squeezed into an unimaginably minute region. Imagine a star a few times more massive than the Sun, all packed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Researchers have been fascinated by black holes for quite a while. At first, they focused on objects in space so immense and dense that they could trap light. The most striking ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is a few times that of the Sun, gravity overpowers everything else, leading to the formation of a black hole. It isn't easy to detect black holes as they emit no light. However, experts have found ways to interpret their presence by observing their effects on neighboring matter. For example, if a black hole passes through a cloud of interstellar matter, it pulls matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can be destroyed, releasing X-rays as it does so. Black holes also impact their surroundings. They can consume neighboring stars, reduce extreme light emissions, and even influence the formation of new stars in certain regions while suppressing it in others. So how do black holes form? Picture this. Stars, once bright and shining, meet their fiery end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, transform into something many refer to as neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is a few times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these giant stars collapse, something astonishing happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the final defining point for anything falling into a black hole. The clock ticks at a different speed compared to ours on Earth. Occasionally, when two smaller black holes collide, they merge to form a much larger and even more terrifying black hole. If a black hole interacts with a neutron star, it creates an incredible nightmare that defies understanding. Scientists have been grappling with the scale of these cosmic anomalies for decades. Black holes come in two sizes, small and large. However, there's a bit of a misconception about them. Small is relative when it comes to black holes. Very large black holes, remnants of massive stars, can be as much as 10 million times the mass of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's a staggering number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes exist at the extreme end of the scale. They are millions, if not billions, of times larger than the Sun. These occupy the centers of massive galaxies, including our own Milky Way. They seem like a massive dead space, pulling everything toward them. The renowned physicist Stephen Hawking studied black holes throughout his life. His theories were well established, but some of his ideas proved hard to confirm due to a lack of advanced technology. However, there is now hope on the horizon, a revolutionary instrument that is changing everything. The James Webb Space Telescope, JWST. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to human creativity. Sure, we've launched other space telescopes before, and they've done their job skillfully, but this extraordinary machine is on a level that is truly remarkable. The JWST makes the Hubble Space Telescope, which has served us for so long, look like a basic tool. The price tag of this colossal marvel is a staggering $10 billion. Yes, you heard that right, an eye-watering number of zeros. The joined endeavors of NASA, the European Space Organization, and the Canadian Space Organization have worked to rejuvenate this wonder, alongside huge commitments from over 300 universities. However, we shouldn't fail to remember the risks associated with such a great endeavor. I understand that this isn't an undertaking for the faint-hearted. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already achieved several remarkable milestones. It traveled more than 1 million miles to reach its orbit around the Sun, where it will reside indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sunshield and enormous primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after deployment and adjustments, the telescope is nearly ready for full operation. One of the most exciting moments of the James Webb Space Telescope's mission was when NASA announced that it had captured its first significant images of starlight. The first image taken by the telescope was of a star called HD 8446, revealing a series of 18 scattered bright spots from the star's light, gathered by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446, where 18 unfocused duplicates of the star were arranged in a deliberate hexagonal pattern. Once the observatory aligns the individual segments of the primary mirror, it will begin the process of stacking images on top of each other to create one clear view. Thanks to its state-of-the-art technology, the JWST will help scientists study the earliest stages of the universe after the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge, by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists find exoplanets, which are incredibly difficult to detect because of their interactions with their host stars. Observations can now closely study these planets, allowing scientists to analyze their atmospheres and explore the conditions necessary for life. The JWST's capabilities will help scientists better predict whether specific planets might be habitable. Beyond studying planet formation, scientists focus on these worlds to understand how matter is organized on a massive scale. This, in turn, helps us understand how the universe has evolved, forming the galaxies we see today billions of years later. One of the JWST's goals is to look back at the earliest galaxies to better understand how they formed. Scientists are also working to determine how we got the merging of galaxies to unravel the universe's story. The James Webb Space Telescope, JWST, is surely at the forefront of this fascinating scientific journey. With its ability to observe distant galaxies, stars, and even exoplanets in extraordinary detail, it has already provided a glimpse into the depths of the universe and shown that we may not be as alone as we once thought. One of the most staggering discoveries from the JWST is its ability to detect molecules, such as polycyclic aromatic hydrocarbons, PAHs, around truly massive black holes in galaxies billions of light-years away. These organic molecules, which could potentially be the building blocks of life, are found in dense gas clouds near black holes, hinting at the possibility that life could exist in places we previously thought were inhospitable. The fact that these PAHs can survive near black holes, where the gravitational forces are extreme, further fuels the idea that life might not be restricted to just one corner of the universe. Additionally, the JWST has also uncovered the oldest black holes, dating back to the early universe, just 570 million years after the Big Bang. These early black holes are not only massive but also challenge current theories about the formation and growth of black holes in the early universe. Astronomers now speculate that there may be even older black holes yet to be discovered, hidden deep within the cosmos. As well as examining black holes, the JWST is providing critical data about the formation of stars and galaxies, shedding light on the processes that led to the cosmic structures we observe today. It is also enhancing our understanding of exoplanets and their potential to host life. By studying the atmospheres of exoplanets, Scientists can now detect the presence of gases such as water vapor, methane, and carbon dioxide, key elements for life as we know it. The telescope's infrared capabilities allow it to identify faint signals from these planets, even those light-years away, helping to answer the age-old question: are we alone? These groundbreaking discoveries also bring us closer to understanding dark matter, a mysterious substance that makes up a significant portion of the universe's mass but remains elusive to current detection methods. Some theories suggest that primordial black holes formed shortly after the Big Bang could be responsible for dark matter. If this hypothesis proves true, it would open up a new avenue of research into the very fabric of the universe. As the JWST continues its mission, it will undoubtedly revolutionize our understanding of the universe. The possibilities it opens are vast. From uncovering the origins of galaxies and stars to exploring the potential for life beyond Earth. Each new discovery will bring us one step closer to solving some of the universe's most profound mysteries, ultimately helping us understand where we come from and whether we are truly alone in this vast, enigmatic universe.